Good evening, everyone. Welcome to AI for Developers. My name is Jackson. I'll be your host, and I'm one of the organizers of AI User Group. AI User Group is a community of professional marketers, designers, and developers interested in the latest AI tools and how we can apply them to our professional day-to-day. So we host 3 events: AI for marketers, AI for designers, and AI for developers. So this is AI for Developers. A few announcements before we get started. Thank you, LinkedIn live stream participants, for being here. Appreciate your attendance as well. Agenda for today. We'll start first with George, then we'll hear from Davit, and then Varun. And then at 8 o'clock, we'll do a 5-minute open mic. So if you want to come up and introduce yourself where I'm standing right now to the LinkedIn live stream and everyone else, we'll take 5 minutes to do that just to kick off networking. We'll start networking at 8:05 and have some pizza and some drinks. So that's the agenda. Doors close at 8:50 tonight. What else? Call for speakers. We're always interested in finding great speakers. We have a lot of AI tool creators, but we also like users. So if you're working with an AI tool or AI-powered workflow in your professional day-to-day as a developer, and you can show it in a demo, we'd love to hear from you and have you present. So this could be a RAG workflow. This could be using a code generation tool, for example, in production. So if you're willing to show it, come talk to me. And or email me. The email I used tonight, that's my email, jackson@aiusergroup.com. Next presentation slot's June 26th. Okay, without further delay, let's get started. Our first presenter is George Roth. George is AI and Document Understanding Evangelist at UiPath. The title of George's talk is Deliver Gen AI Through Automation. Please help me welcome George Roth.
Thank you. Thank you, Jackson. I met Jackson at their wonderful event, which was the first event, I think, that they organized, the community event in San Francisco. And it was an amazing thing to participate and to see this great presentation. I can't wait to look at the Llama Index presentation, the next one. I'm a big fan of Llama Index too. So I don't know how many of you know what UiPath is. UiPath, I joined UiPath a few years ago through their first acquisition. I had a startup, and basically we developed an intelligent document processing platform, which was acquired by UiPath 6 years ago. And then I joined UiPath. And I went through UiPath, started as an RPA company and so on, and they had to rebrand so much. And especially now when this AI revolution, is going on, it's really hard for the companies to keep the pace with this technology, how it's developing. So what I will try to show you, the way how we say that one of the ways to deploy AI in the enterprise is through this AI-based automation platform that we have. Our CPO likes to say that the AI is the brain and our platform is the muscle. So makes everything what the AI decides actionable. Can you hear me? Oh, sorry. So what do I have to do? Oh. Sorry about that. I think I didn't. Now can you see it? Cool, sorry about that. Basically we know that AI, it's basically start to surpass what the humans do in certain domains. And still, if I think you share the same experience with me, there is it's a big caution in the big companies to start using this. And these are a few of the causes which we encounter. The UiPath platform is basically, we provide a platform that has a lot of products in it and allows basically to get context from different sources and actually, to get all this context and we do a discovery of different things, and then we use generative AI. We integrate with all the models with most of the models on the market. And definitely we have something called a specialized AI, which are, you will see specific AI models, even small LLMs, which solve the different problems. And of course, you cannot deploy this without having a trust layer, and we will talk about that. And definitely one of the big things that we talk about, we make everything actionable, so that everything we determine through the AI, we can bring to the enterprise systems in order to make everything actionable. Now, everybody reads about Copilot, autopilots, and all these pilots which appear. Basically, in our opinion, this autopilot is nothing else but a way to deploy AI packaged together with some specific workflows which help different activities. And these autopilots, and where we use the generative AI, it basically helps in different things. So first of all, through generative AI, you enhance the quality and accuracy of the activities in an enterprise. Then you supercharge the productivity of people. And then you can learn to automate more and more. And we will show you examples of all of this, what we mean by that. So talking about how we enhance the productivity, the target of our autopilots. So Microsoft has copilots. Now we have autopilots. Everybody asks us, do we compete? We don't compete. We are frenemies. So we basically work together. Copilot can call us, and we can call Copilot. I don't want to compete Microsoft when they work with the Office products. You cannot. But they cannot do certain things that we know. And so we work actually very well with Microsoft also. And I will show you one of them, the autopilot, what the autopilot does for the developers. Hopefully we'll hear the sound too. The sound?
Efficiency, minimize errors, and supercharge your productivity to automate the most important processes. Today, we're automating the process of onboarding customers in SAP by creating customer data and populating it into our system. Typically, this system is not accessible to new customers for self-service, so we will build a public app for this. Previously, it would take developers a significant amount of time to get everything working end-to-end. With the help of Autopilot, all I need is to take a screenshot and to upload it to apps. Using our computer vision and large language models, a new application is built in seconds. With just a few clicks, Autopilot generated the required fields to onboard a new organization. And it's not only the front end, since the data service is generated automatically to store a record every time the application is submitted. Apps allow me to write expressions to fully customize the task I want to accomplish. With the help of Autopilot, I will describe in natural language what I need, and it will help me by generating the expression. I can also ask for more changes, like making the input to lowercase. Of course, for this process to be fully automated, I want to save the data in some external systems. For this, I will describe the job I need to be accomplished. And I want to create an account in Salesforce to use the recent UiPath capabilities to summarize, to notify the team over Slack, and to create a task into our tracking system. Once again, Autopilot will assist by converting the description into automation steps that can be configured and customized in Studio. These features enable developers of all skills levels to accelerate the creation of automations and to significantly reduce the complexity, making it a truly low-code experience. The output is an automation constructed using our activities based on the steps described in natural language. Autopilot populates fields as instructed, such as filling in values for the team channel. For the next step, we want to use automation to input customer details automatically into SAP. Additionally, Autopilot can analyze the target application, and based on our user description, it can understand the elements, identify the target selectors, and construct a sequence of activities to fulfill the task. In our case, we want to fill all the details. At any time, we can monitor the output and we can review the corresponding activities and the identified elements. For today's automation, I would like to also input the standard address section so I can send a new request to expand the already identified steps. Once I am satisfied with the results of the UI automation via Autopilot, I have the option to return to the Studio Designer to refine and complete my automation by doing any necessary adjustments, ensuring that the automation operates smoothly and meets the required specifications. For the final step in my automation, I'm required to input a value for the account number in Salesforce. In accordance with company policy, this ID must be a unique value which is achieved by appending a timestamp. I will explain this to Autopilot to demonstrate how simple it is to generate expressions from business specifications. Empowering developers to reach their peak, Autopilot for developers is a game changer. By transforming complex automations into a few simple steps, we're not just saving time, we're crafting a revolution in efficiency. Let's explore the end-to-end flow now that the automation is live. Any supplier will be greeted with a welcome email that invites them to self-onboard via an app. This public app, generated with Autopilot, can be accessed by any vendor and then can provide the needed information. Submitting the form information will trigger the automation that onboards the vendor in SAP. This is using your automation, and we can see the robot in action. Once the registration is complete, the vendor will receive an acknowledgement. Besides SAP, the account is also registered in Salesforce, and a follow-up task is created in Asana. Remember that all these steps were sent to Autopilot in natural language, which assisted us in building this automated process in less than 5 minutes. Autopilot for developers.
So basically you saw that the whole development works. It's happening, we have a studio. There are 2 studios. There is Studio and Studio X. It's web-based, or there is another older version too. And there is a dialogue between the developer and the Autopilot. And there are some functions which actually will be exposed through an API with a new version which is coming out. You have text to workflow, text to regular expression. You have another application of a document, which can be an image or a PDF to UX. So there are these conversions, these functions which will be able to be used by an API. Another interesting part is the effect in the testing. Actually, we have a testing team, and you'll hear different accents here. The previous accent was from Romania, where we have a development. Now you will hear an Austrian accent, where is our testing team. And you will see how this guy, Ingo Philipp, is a fantastic presenter. He's one of the leads of the testing team in Vienna. And you will see how they use Gen AI for the testing.
Hello everyone, and welcome to Autopilot for Testers, a collection of advanced AI capabilities designed to revolutionize testing as we know it. With Autopilot, you can generate manual tests from requirements in Test Manager, automate these tests in Studio, and gain real-time insights into your entire test portfolio in Test Manager. Now let's see it in action. In Test Manager, simply go to your requirements, select one of these requirements, and click Generate Tests. Autopilot then gets to work analyzing the details of that requirement to promptly suggest the top manual tests for that requirement. After that, just select the tests you want to create, hit Create, and your manual tests are ready and linked. Now let's head over to Studio to automate these manual tests. To do that, select one and with a single click, bring it into Studio. Now this converts the test steps of that manual test case into code comments. With your object repository holding the technical components of your application, Autopilot has all the tools it needs to work its magic. Just hit generate code and it begins. Autopilot then analyzes the test steps, taps into our driver framework, and there you have it. Your manual test is now automated. Now let's head back to Test Manager to see how Autopilot helps to analyze the test results of all the test cases we just automated in Studio. To do that, let's go to the test results section, where all your test results are listed. Now to make sense of these hundreds of test results, simply click Generate Insights. Autopilot then sifts through these large volumes of data, and once done with analyzing, Autopilot shows you which tests are failing, gives you insights about why they are failing, and also provides actionable recommendations to fix your failing tests. Now that's analysis made easy. So that's the essence of how Autopilot brings the power of AI to every phase of testing. So what's the motivation behind Autopilot? Well, we developed Autopilot with one goal in mind: to enable testers to always perform at the highest potential. In essence, we aim to empower every tester to be the best. Thank you so much.
So you saw here a combination how you are integrated and using the Autopilot is the agent, which calls different products which are on our platform. It was Test Manager, then you had the Insights, which is our data analytics, and these combining this together based on commands, the user basically always is in the loop, but it's only directs what type of test, and they actually generate test data too, synthetic test data for your test. So this is one of the most successful usage of our platform. It's a very, very high growth of this test manager. Now, the ideal, which everybody talks about, is to have an autopilot for everybody. And I recently, you probably heard the Mustafa Soleiman talking about his vision about what is the future of AI with these agents when his son is asking him what AI is. And he explains that basically it's an agent which basically will help everybody in what he's doing. And obviously we are doing this autopilot for everyone, and you can see that we have all these tools there. So we have an integration service. We can integrate very easy with any application. We acquired a company called Cloud Elements. And then we have these functions which basically understands the way you work. We have even a task manager which you can look at people, what they do, and generate workflows. And I will show you, and this is a long one, this basically it's an agent I can show you after, it's pretty long. It basically shows how you upload the conference, and then the agent basically generates everything for you, checks your passport, also reserves the hotel and everything. If you are interested, I will show you after. I'll show you here, this is an example of the physician, how it uses. I'll show you this one, which is, I think is pretty interesting.
In this video, we'll showcase how UiPath's Autopilot for Assistant can provide real-time support and preparing a physician for a patient encounter. I'll be playing the role of a surgeon who is about to see a patient referred to me by his PCP. I'd like to walk into the conversation with a better understanding of the patient's medical history in order to provide better and more efficient care. The patient's medical record contains information including his registration form, medications, summaries, SOAP notes, lab results, charts, diagrams, and more. We'll upload this record to Autopilot and begin asking questions about the patient's condition. The first question we'll ask is about the current diagnosis in order to get some basic information. Autopilot will take the uploaded document and leverage a large language model to internalize its information and allow for Q&A. It will then take the question I've asked and respond accordingly. You can see Autopilot has recognized the patient has been diagnosed with a recurrent right angle hernia, while also providing some other relevant context, such as the patient's name and previous surgical history. The next question we'll ask is about the patient's current medications, as we'll perform a brief drug utilization review to understand how we might proceed. Again, the correct information was extracted along with relevant context, including that hydroxyzine should not be given intravenously, even though this was simply listed as not to be given IV in the chart. An important note is that Autopilot can be trained and customized as you like. For example, if the physician would want a common set of information before each encounter, this could all be retrieved with a single question. Suppose we've completed the encounter now, and I'd like to wrap up by closing the loop and kicking off the next phase of the patient lifecycle. First, I'll help my charge capture and coding teams by providing an initial ICD-10 code, hopefully avoiding the need for a follow-up asking for more information, saving more time down the road. What you're seeing here is Autopilot wanting to gather additional information in order to process this request, so it has triggered an AI automation to help. These automations have not been pre-built by anyone. Rather, the large language model will create one on the fly, inferring the process steps along the way. As the process completes, we receive the diagnosis code. If the process generated by the AI automation is one I'd like to keep, share, and reuse in the future, I'm able to open it and have Autopilot in Studio create a workflow using the exact steps performed. Either myself or professional developers can take that workflow and edit it if needed. Lastly, in order to keep medical continuity, I'll provide the patient's PCP with my recommendations and close the loop. In this example, I will simply ask Autopilot to send an email, but I could just as easily ask it for something else, such as submitting notes into the EMR. If you notice, I asked to send the email to the PCP, which was not referenced previously. Autopilot is able to understand who this is based upon the original document and pulls Dr. Moore's name. For this demo, I will send the email to myself, and in a few moments I have received it in my inbox. To summarize, you've seen UiPath's commitment to embedding advanced AI and large language models into its core platform, enhancing the productivity of all users. This demo focused on healthcare providers, but could be easily applied to other areas, such as prospective utilization management reviews and intake specialists helping potential plasma donors work through an SOP. Thank you for watching.
Now, I will finish with this one. Everybody loves IRS. So we are working with the IRS, and I'll show you an autopilot. So we have to watch what we do with our taxes. So I am asking what are the open cases. I'm an agent. And I have a conversation with Autopilot about what I want to do. I search the tax code, whatever. Obvious, this is, we call this context grounding. This, the whole Autopilot, it has to be pre-trained. We have a whole support for RAG and context grounding because you have to upload all the legislation, whatever they use. You start taking the documents in. It uses here forms and any other documents and uses our document understanding platform in behind the scenes to extract the data. And then it asks, are there any discrepancies between the reported data in the files? So if you have multiple files, it actually it can find problems, and it will find you the problems here between certain fields that you wrote in one way in one place and another way. I'm sure this can be used in New York right now. And basically, it's an agent which helps the work of the government. So I stop here with the demos. After I can show you many demos, just tell me what type of industry are you interested in. So obvious, it's integration with ServiceNow. You can create tickets, and ServiceNow takes care. You get these long time workflows, which allows you to keep the human in the loop. And if people have to approve and do different things, this workflow is still open until the whole thing is finished. So I can show you, we have all these predefined models, tons of models. We call these specialized models, which are predefined. You also can develop models. We have two products, which is called comms mining and process mining, document understanding. The CommPath is an LLM specific to analyze communications with customer, developed in-house. And we have the DocPath, which is helping you in extract data. We are also using active learning. If you don't know what it is, I'll be happy to tell you about. It's a method to optimize the labeling, reducing the labeling, and label only the things that you are interested in. And basically, we have all these, we have this studio, and actually in these activities, we provide all these tools that people can use when you develop everything, these AI-related tools. We integrate with all the LLMs. And because we talk about the trust layer, we have something called the trust layer, which provides the functionality. Each time when you go out and you use an LLM, it has to go through this. And then we ensure we have rules, we have PII and data filtering and all this context grounding, which all are under the supervision of this gateway, which ensures that we stay we stay compliant with all the rules. So basically, I will finish here. We can talk after. You can try out Autopilot if you go to UiPath.com Insider. And I'm open to discuss more and more details of all this and to show you other demos if you are interested. Thank you very much. I went over the 20, but
yeah. Well, I think that's fine. Are there any questions for George? Okay, we probably have time for one question before we move on to the next speaker. If you guys could just help me pass this mic, and then just please stand so we can all see you, if you don't mind. Thank you.
I just wanted to ask about this. I think what I'm seeing, I guess want to be clear about that, is when you are creating a workflow process, for example, there's things that you do repetitively. And you might be using custom-built software, your own app or own web app that's within your organization, like a banking institution, for example. So is what I'm hearing that you could kind of automate some of those common process steps, and so you don't actually have to sit in front of the screen and write it, but it's not quite necessarily even using APIs, it's kind of using the user interface of the product? Because that was actually what I noticed was on one of these, the very first demo you provided, it looked like the app, the UiPath app that you created was going back into an SAP screen and filling information out.
Great question. So one of the thing how this company started, that's why it's called UiPath. They started as a UI automation software, which is actually in the RPA language was the attended bots. And basically you can go on a screen, and it's called UiPath because if you have a screen, you have a way to access every field there through a path. And that was their observation for their startup. But what we do, we have API automation because we have an integration service. We acquired Cloud Elements, which it's actually a hub-spoke type of integration service. And we have also UI automation, which is for the systems who have no APIs. So you can do both. So for example, depends on what system you work. So we cover every way to integrate with, for example, we can do even old systems through Citrix doing the screen type of integration too. So there are two of them. Thank you very much.
Okay, let's give George a round of applause. And George will be around for networking as well. So if there's any follow-up questions, please see George when we do networking. In the meantime, I'd like to welcome our next speaker, who is Davit. Davit is the founder and CEO of Activeloop. The title of Davit's talk is Fine-Tune Llama 3 and Build Accurate Knowledge Retrieval for Healthcare. So really looking forward to this. Help me welcome Davit.
So actually, we changed the title last minute. Hey, Ron. Glad to be here. So today, actually, I'm going to talk about why RAG is not enough. Before we get started, I'm going to put this slide. I put this slide a year ago as well at this moment, and I don't think a lot of stuff that changed since last year. And those problems, they still exist in Gen AI applications in production. We have super cool, shiny demos, but they are not yet ready, production ready to be deployed into enterprises. We have a lot of non-differentiated businesses using GPT layer. And thanks to Llama 3, it gets even further non-differentiated. The problem is that, yes, LLM input size got slightly bigger, but they're also very expensive. And there are still trade-offs how to get the prompts and the context into the input. And of course, being in the vector database for the last year, the vector search does not actually solve the retrieval problem, and still a lot of issues there. And many of them can't handle many modalities. So before we get into why RAG is not enough, let's get back to what is RAG. And RAG is just a fancy name for enterprise search. What's happening is that you have a query, you get this query into an embedding space. Basically, you have a vector. You run this vector inside a vector database where you compare it to other vectors that already exist from the corpus data, and then you find the top 10 relevant ones and give this into the context along with your prompt to the LLM, and you get the final result. And what happened maybe last few years is that thanks to GPT-4 and large language models, those embeddings became so good, they bypassed more lexical search algorithm that we used to write, such as the BM25 that Elasticsearch is using. So that has been the biggest change. And then additionally, now you have a final LLM synthesizer that can summarize the data and give it as an output. But for context, they are, instead of being reasoning engines, they are more like journalists. They can summarize pretty good information. So the challenges that we have seen across enterprises, even before giving the insights and finalizing the output and the answers from the data, is actually bringing this data to the structured data sets you can train or run your LLMs. What we have seen is that you have many different data sources, such as Snowflake, could be Postgres database, running on your service, keeping your user information. Maybe you have a lot of PDFs, unstructured data, sitting on top of your own S3. And now you also have a plethora of options to run embedding vector search or database to store them and then run search. And you have to cross-link across all these different 3 data storages. And then now, let's say you want to train your own model on your own specific data. You have to copy this data to your local machine, do the training process, and run this through loop. And you might have to also have a data scientist that's very specialized on building this data engine. And what we do differently is that we unify the 3 different data storages together into a single deep lake datasets that sits on top of your own S3, and then very efficiently stream this data to your pre-processing, training, and inference. In short, we do have computed storage isolation. We support multimodal data, not just vectors of multimodal data, but also text, audio, images, video, audio. In healthcare space especially, we have DICOM files that you can store CT scans or X-ray images, and you can stream, query, and visualize. But this talk less is about us and what we are doing at Activeloop, and what we think how the RAG future is going to look like. So this is very similar to what Tesla's data engine looks like, where on the laptop you start with a data source. Maybe it's your corpus, your PDFs that sits on top of your Dropbox or Google Drive. And then the first thing you do is you put this into a vector database. In this case, I chose obviously Deep Lake, but you can choose any vector database there. And then next is you take this data and then plug this into your reasoning engine. And the reasoning engine is using large language models that are deployed and then can do answer on top of the context that you provide. However, so far when we call a RAG, there's not any feedback loop that's happening inside. There's obviously some folks call it RAG 2.0. Some folks tried other methods like Roth. That's what we focus on this talk later today. But the main key thing is that similarly, what you had with self-driving cars is when you deploy the car on the road, you collect a lot more data, you find these edge cases, you then fine-tune back your model until the last mile that's nailed down that you can deploy this safely, and what we see with Waymos and Teslas on the roads. So there's one key piece that differentiates Deep Lake compared to other vector databases is the deep memory layer. Think of this as a very thin neural network. I wouldn't even call a neural network that sits between the vector search inputs and outputs. And what does it do differently is that it can train or basically try to transform the embedding space such that your vector search is more relevant, tailored to your specific data. Think of the following. You have a corpus data set that sits on, when it's embedded, it sits in one planet. And then when you have questions, those questions have a question mark. They are paused differently, not from your corpus data, and they sit in another planet. And what deep memory does is build a bridge between these 2 different embedding spaces or subsets of those spaces so that you can easily go and traverse from, let's say, question to the corpus land, and then from corpus land back to the question land. And the main key thing, it specializes based on your input queries that you have provided. Then there's also this method called Raft. So what Raft is done by Tianjun Zhang, sorry if I mispronounce the name, is following the following concept. So first of all, if you have an LLM and you ask a question, let's say it does have no any connection to any vector database, no internet, it's just the LLM that has been trained on next token prediction across the whole corpus of the internet. Think of this as like kind of closed book based answering. And then RAG, or vector search plus LLM, is the open book where you have access to the data while you're answering the question. And access not just to the old data, but the relevant data. And then what Raft proposes is, can we actually go and fine-tune the LLM itself so that we can easily navigate the context when we get, let's say, the top 10 relevant corpus data and find the irrelevant ones. And the way it does is that you take the questions that you have, go and run a vector search, let's say generate 10 relevant examples for the specific question, and then now you feed irrelevant questions inside, or sorry, answers inside, and then you teach the language model here to be able to disambiguate which element is relevant to that answer or not. And what we achieve here, which is very interesting, is the following result. So first of all, on the left, we have Llama 3, 8 billion, and thanks to Meta again for releasing this awesome model, without any context. So we take the COVID-19 data set, ask a lot of questions, and then measure what's the accuracy of those answers. So if you take a Llama 3.8b, it will naively get 49% accuracy. Then let's take the same question and ask this to GPT-4, again, without any context. There's an improvement, yes, that's great, with number of parameters that inside GPT-4, we get about 65%. Again, this is no any chain of thoughts, no any reasoning on top, just question and answer directly. And then what we do here is that we take this small 8 billion parameter model, add a vector search. Again, there's nothing fancy. Take this vector search, add into the context, and now we have a boost of answers that's even better than GPT-4. Now, again, so 75% is not bad. Basically, you ask 100 questions, 25% of them are wrong. You definitely don't want to deploy this into any hospital, into any healthcare scenario that's super sensitive. We add this deep memory functionality here that whenever you run the vector search, instead of bringing the cosine similarity, which is the measure that you use to bring the relevant context, now we try to fine-tune this embedding species or train a deep memory metric that can bring the more relevant that has been fine-tuned on your own data set. And again, we are just using Llama 3.8b, and it boosts the accuracy here. In this case, 7%. We have seen in the training set about plus 4%. Sometimes there are use cases and applications that can go up to 22%, what we have seen. And this is like a significant improvement compared to what you don't have with Llama 3. And then what we do here is that we take the Llama 3.8b with a naive vector search and then fine-tune the LLM synthesizer that gives you the final answer using Roth method. And what we can see that there's a significant improvement that goes to 79%. And if we combine this both methods, then we get about 89%. Obviously, 89% is not enough to put this into production in any very sensitive applications. But what this gives you is the baseline that you can get started and then build your own RAG data engine and then start iterating and improving this accuracy to get 95% or some use cases that really require 99% accuracy. So that's the big basis of it, and really thanks to Emanuele Finocchi who did work on this project. And what I can do is I can very briefly go over the code. There's a lot of code to go over, and then answer any questions you have. Before get started, any questions you guys have? Okay, great. So basically I have two notebooks that I will quickly glance over, so I won't bore you much, and also the data sets that we can look over. So this one does the training piece. So what we do here, we first of all create the Roth dataset. So the Roth dataset is used for training or fine-tuning here the Llama 3. We define the dataset in Deep Lake. We create tensors, each for this, for the question, the context, the answer, and the instruction itself. And then we add this into the Deep Lake datasets. So once the datasets are inside Deep Lake datasets, then we can quickly check the dataset in the UI itself. So here we have about 1,500 chunks that will be used for training the Roth model. You can see here's a prompt that's inserted and the ground truth answer that is expected from the model to be answered. Then we load this is on using TorchTune. So Emanuele created a fork of TorchTune, which hopefully will be soon merged to TorchTune, that can directly use Deep Lake and showcase the Roth training inside. We download with a permission from Meta the Llama 3.8b. After the download itself, this kickstarted the training or fine-tuning of the model. So you can see here it uses LoRa single device Deep Lake Roth YAML file. Again, on TorchTune, you won't see it now, but you can go to the Emanuele's version of it, and you can find the training instructions there. This will take about 30 minutes, so obviously I'm not running now. Create the dataset, then what we do is interesting here. We use GPT-4 to actually generate questions and answers. and then the generation of the questions are actually based on the corpus data that we have from Core 19. What happens after this generation itself, we create the vector index and then embed the data as well. And we can go into the following Activeloop deep memory biomedical dataset. This is the corpus itself that you see. So you have the embeddings using, I think, just ADA2 basic model from OpenAI, the metadata relevant to that, and also the text dataset. So it's pretty simple, straightforward, structured dataset that you can run vector search on top. And then additionally, what we do is we also, as we mentioned, we generated the questions based on the context itself. And now we have another dataset that has about 1,000 questions per each chunk. And then not just the questions, but also the ID, where this question, let's say in this case, is answering which corpus item is there. So basically, you create a synthetic dataset from the dataset that you already have if you don't have any questions. Usually what we tell to our users is that, hey, if you have a system that's already in production, your users are likely asking a lot of questions. Takes this data, it's much better than GPT-4 generated synthetic questions. And then there's the evaluation step, basically, which I have tried to create last minute here, another much simpler model that will showcase what you need. So here, basically, we load the Hugging Face token, the Activeloop token, and OpenAI API token, load a question. This question is like, what caused the cluster of pneumonia cases in Wuhan? And then here's the answer. And a very naive example, I won't surprise anyone here, is we load the model itself, get the question, there's no any context, so you don't run any vector search here, and then you give it to the pipeline, and then you get the answer. And what becomes different when you use Roth fine-tuned deep memory model is, again, you just, instead of using the default Llama 3 model, you can now use the fine-tuned version that Emmanuel uploaded as well. You can run the pipeline. Now, since we need to run the vector search, you need to also create the vector embeddings, load the dataset itself that we have just shared with you. And here's the core important piece is now you have the question, you take the question, obviously just run a vector search, gets the relevant examples, and put it into the context. And there's one key variable that we have is this called deep memory true. And what's happening is that in deep memory true is whenever you give the embedding is transformed into learned representation that increases the accuracy of the relevant context that is being brought back to the LLM context, and you get the final answer. So hopefully didn't get into too much, but yeah, so this has been a basic example of how you can improve your own RAG pipelines, going from using like 8 billion parameter model that's can be deployed in production at enterprises and overpassing GPT-4 accuracy here. Thank you very much.
Let's start Q&A. Any questions for Davit?
Yeah. Hi, David. First of all, this is an awesome presentation. Thank you for putting the graph. That way we can compare and see how it does versus the out-of-the-box Llama 3. So my question is, you mentioned you did not add any reasoning or chain of thought. I wonder how deep memory could fare if you compare it against the best possible model. Have you tried running that test?
That's a very good question. So we haven't yet on this one example, we just got the results yesterday, with chain of thought. I think the chain of thought will improve the LLM reasoning piece, but it's still the vector search is the same. So if you have, let's say, not relevant context, then the results, so with chain of thought, you sometimes have the butterfly effect, where one small error that gets propagated through the chain that you're building. Then the likelihood of having the repeated elements that are wrong in the context is potentially increase. This is just a hypothesis, right? We have to run the experiment and see and make it worse. So what's the next step here that what we were discussing is that In addition to running chain of thought, you also run prompt optimization. So those are the two steps that are left, and hopefully push the last accuracy way higher that passes for some applications to be deployed. But we haven't, to be honest, tried it yet.
Yeah, once you do, I'd be excited to see the results.
Yep,
Thank you.
yep. And take these results with grain of salt. Like this is very specific to this data set, and like try run on your own data sets and try to get those benchmarks and comparisons, and not just look into a single accuracy metric, but there are like many other RAG metrics that people meet, like including recall or others. You can precision, etc.
Yeah, right. Thank you.
Any other questions for Davit? So Davit, speaking of accuracy and LLM evaluation, what healthcare use cases do you think are suitable for LLMs at this stage, if any? And if not, what sort of accuracy levels can we expect to achieve in the near future?
Yeah, we have a customer, Mona. They're deploying this to one of the largest hospitals in Brazil, I think Einstein Hospital. And what they do is that it's very remarkable. They take a lot of protocols. So whenever you, let's say a physician prescribes anything, they actually have to follow a protocol and then put these protocols into a vector database. And then when a patient asks a question, they quickly match this result to the protocols and bring back to the final LLM synthesizer. So here you have physician in the loop, so it can actually detect if there's anything wrong or bad. But what we have seen is like if you specialize in a very specific use case, which is this protocol search, then you can get the LLM answer. I don't want to put numbers. I think they have their own numbers, but it's like 90+% accurate for very domain-specific use cases. So that's one example. That's publicly we can talk, but more. I think currently I will hesitate and make sure that like you have full understanding of how this LLM works before you put this into a hospital. And what we have seen actually way more use cases in medtech or like life sciences verticals where you don't have this deployed in a mission critical scheme. So I wouldn't deploy now in mission critical use cases, but for like this kind of back office work, this can really help. Also another use case, which is very, very apparently growing, is the transcription. So whenever a patient talks to the physician, like taking the doctor notes, this is like, I think now is like deployed in many, many hospitals. So these are some of the use cases you can use it now.
That's super cool. Any questions from the audience for Davit? Okay, we got another question. What use cases outside of medicine have you seen as successful using LLMs in production? And what sort of accuracy levels are required for these use cases, if you can talk about them?
Yeah, definitely. So in healthcare, you won't use the biggest superpower of LLMs is the hallucinations, but you need to pick such use cases where they actually are super powerful. For example, like legal space. In legal space, whenever you're changing any definition or inside a contract, there's like a big, you can have like 3 lawyers arguing differently with each other, which definition is great. And I have seen it myself, like when you go to a lawyer, one lawyer say that like you have a cancer, and the same lawyer with the same definitions can say you don't have a cancer. Cancer is an example from the healthcare, but there's like a big problem in the contract itself. So I think the LLMs and their hallucination superpowers are super domain specifically used there. And we have a customer there, Hercules AI Zero. They're using Deep Lake, deployed this in the lawyer firms inside their own data centers. So there's like the data sensitivity is a big issue there as well. So anyway, the legal space, and I can't wait to automate the lawyers. So I think that's a big space that will be disrupted. And every text in and text output use cases with human in the loop. So again, there's no any full automation there. I think we are not 5, but more than 10 years away from having fully automation, but you can make now, like let's say lawyers 10x more efficient by enabling them with LLMs.
We still have a little more time. Any other questions from the audience for Davit? Oh, George, hold on, let me hand you the mic. I can only go so far here. Can someone help me pass this to George?
Thank you.
So, David, I have a question because you mentioned the lawyers. The lawyers don't speak English, they speak legalese. In your experience, how can you train Llama 3 to really understand the legalese? Because even the humans don't understand that.
That's a very hard question, but I have actually, the way I think is, if you read the contract, it's very similar to the code. Like when you program, right, you import, I don't know, deep lake, import NumPy, and then run computation, or you import your local library that you have built locally. It's very similar to the contracts. They can import, let's say, California law, then they can import your company law, and then start building their own definitions and thesis, and then make a contract at the end of the day. So I would say it will be automated even faster than writing the code, but you need a lot of human-in-the-loop lawyers to be able to do that. And lawyers who are open-minded, and I know a lot of them, they actually want to embrace to automate a lot of work there.
Thank you.
Okay, one more question, because we have time. Davit, what can you tell us about, could you speak briefly on LLM evaluation? And I just want to ask, can you talk a little bit about your internal process for evaluating LLM performance? And if you can't, can you tell us about some other tools that are more public? Because some things in LLMs are hard to score in terms of, like applying a number is always nice, but I'm just curious how you go about this.
No, man, I'm not an expert in LLM evaluations, and I would love to see an expert in this field. There are a lot of benchmarks, right? But those benchmarks can be easily tricked over if you overtrain those models on the training sets or the validation sets, so nobody knows what happened with the data sets that have been fed into the most recent models. You have also these arenas that can do more like dynamic evaluation of models. We have companies and partners on our side that are building evaluation tools. One of them is Weights and Biases doing Weave. We have another classmate of mine from my undergrad doing Context AI. So a lot of folks, smart folks, are working in this field and trying to build the de facto standard for evaluations. But like, since you are operating in text space and it's like super hard to evaluate text, it's a hard problem. It's like the same as when you make up exams. And then, like I did myself when I was doing my PhD at Princeton, I did create an exam for students who are taking neural network course. And we wrote a question. That question could have been answered 10 different ways, and all of them were right. Like I remember there's one question that's interesting to remember as well. We wrote like, hey, can you come up with a neural network on the paper that can solve this and the and/or problem, NOR problem using logic. So a lot of people had, subset of them had diagrams, subset of them just wrote the weights on the papers. So what we did is that we created the simulation of a neural network in Excel sheet, in Google Sheet, and then we just transfer the weights and then start like normalize the answer and then start evaluating if this is correct or not, because there's many branches you need to check. So the moral of that is that it's very hard to even evaluate human answers, and if not, like the LLMs themselves.
Okay, makes sense. Thanks so much, Davit, and we really appreciate it. Davit will be around for networking too, so if you have some follow-up questions,
Thanks, everyone.
Please do. Okay, our final speaker, Varun, is Senior Partner Engineering Manager at Meta. And the title of Varun's talk is Prompt Engineering with Llama 3. So this will be an exciting overview of Llama 3. So I'm very much looking forward to this. Please help me welcome Varun.
Thanks, everyone. I think Davit made my job easy talking about Llama and how good it is. So that's a good start for me. So let me get started over here. Is everyone able to see my screen? Yeah? Okay. So, hey everyone, this is Varun. I'm a partner engineering manager at Meta. My team at Meta is responsible for increasing the adoption of Llama by making it easy for the developers to use it within their applications. So today, I'm going to be talking about what we released with Llama 3, and we'll do a quick lab exercise, learning about different prompting techniques. So I would like to keep it interactive, so if you have any questions or something, please let me know. I would love to answer them. So Llama 3, so it is the state-of-the-art model that we released, and it is one of the most powerful, openly available model of its size. We released 2 versions of the model, 8B and 70B model, and the way it is really better than Llama 2 and where it gets really good is with reasoning, coding capabilities, as well as following your instructions that is given in the form of like prompt or any other instructions in RAG, etc. To do a brief recap as to how we got here, we first released Llama 2 and Code Llama back in August 2023, and the adoption of these models have been insane. So we have had well over 170 million plus downloads and over 50,000 derivatives on Hugging Face. I want to have a quick question here. How many of you are aware of Purple Llama? Okay, so we have to fix that part. So we have recently renamed it to be called Trust and Safety. So Purple Llama is essentially a set of models and tools that is developed and shipped by Meta that will help you develop your applications in a safe and a responsible manner. So I'm going to talk briefly about it. It's going to be a complete talk on its own, so I'm not going to be double-clicking here, but I'm happy to answer any questions after the talk. So we launched Purple Llama back in December, Code Llama in January of 2024, and 2 weeks ago, we launched the Llama 3, 8B, and 70B model. The Llama Guard 2, so this is essentially provides input and output guardrails, which we announced along with Llama 3. CyberSec evals, so this is a industry first, I would say, in terms of helping you evaluate the LLM's susceptibility to prompt injection, cyber attacks, and code interpreter abuse, etc. So this has not been done before. So if you're fine-tuning your model and you're using it for productivity use cases, and you want to validate how your LLM is doing, this is like one of the good benchmarks to look into. Then we also have Code Shield. This is a Python library that will help you evaluate if the code that is generated by your LLM is safe or unsafe. Because as you rely more and more with the LLMs to generate the code for you, there is a very high probability that these LLMs can introduce cyber attacks or issues that you're unaware of, and you just accept the diff and you move on. So these are like some of the libraries that we also introduce and build as a part of the broader trust and safety umbrella. A little bit more about Llama 3. So Llama 3 was pre-trained with 15 trillion tokens. This is 7 times more than Llama 2 data set, and it has 4 times more code compared to Llama 2. We also introduced a new tokenizer, which is of length 128K. What this means is it can encode your input prompts much efficiently and thus overall improving the performance of the model. With the upcoming release of Llama later this year, we are focusing on building a multi-model, multilingual. We trained the Llama 3 with 5% of data set on non-English languages, covering up to like 30 plus languages. So though we do not guarantee the same performance as English, but this is in preparation of the launch that we are expected to do later this year. I'm not going to bore you here with the benchmarks, but it is published on the paper. You can look into it. But this is like some of the standard benchmarks, as Jackson was asking previously, in terms of how do you compare the LM models. These are like some of the LM harness is one of the standards that typically most of the companies evaluate against. So a preview about what to expect next, right? So we are releasing a 400 billion model. This is going to be big, huge. And this is like a checkpoint from April 15th. This is not so long ago, 2 weeks ago, and the numbers already look fantastic. And we are not done training yet. The training is still in progress. So multilingual, as I mentioned previously, multi-model, multilingual, and larger context windows is what we are looking to do as a part of Llama 3 version 3.1, 3.2, whatever that's going to be. With that, we're going to quickly switch over here to a notebook where we're going to be doing a little bit about prompt engineering here. Give me a second here. All right. So there is a lot in this notebook. I'm going to be sharing the link to this notebook later on. You can run it yourself. It is running on Google Colab. We are going to cover only a couple of topics in the interest of time. But I want to capture, or for you to take away a couple of things from this. One, what is the main difference between Llama 3 and Llama 2 and how it is better? And some of the prompt engineering techniques that is very effective when it comes to working and building your AI applications. So I have pre-run this notebook. Otherwise, you will see these dependencies and everything installed. So I'm going to scroll through and talk over some of the key sections. So this demo uses Replicate, which is a cloud hosting provider that has all the Llama models hosted. So we are just using this as API as a service. So here on the first cell, we just run this method to kind of like copy over the API token from Replicate. So once it is set up, we will be running the inferencing on Replicate. I have some helper functions here that is defined that will allow you to run inferencing on a Llama 2 model, Llama 3 8B, and Llama 3 70B models. There's nothing fancy. It's just basically a REST call over here. So it should be straightforward. Now, let's run some prompts that says like, hey, what's the typical color of Llama? And here you can see Llama 2 comes back and says that, oh, I have to really go find the answer here, right? It's Llama can come in a variety of colors, including white, gray, brown, black, and among others. Now let's see how Llama 3 does. With Llama 3, it is much better. It gets to the bottom of it saying, hey, Llama is usually white, but however, they come in various colors. So Llama 3 is not as chatty as Llama 2. So you don't have to start parsing and negotiating with the responses with Llama 3, so it gets much better. Raise of hands. How many of you know about the hyperparameter, what the temperature does? Okay, so let me quickly go over that. So the temperature is a hyperparameter that lets you set how deterministic you want your output to be. So let's say you set the hyperparameter to be 0, then you get consistent response and the same response from your LLM. But let's say you set it to 1.0, your model is going to be very creative with its responses. So especially when it comes to writing poems, storytelling, etc., that's when you want it to be more creative versus you're asking it to answer something straightforward, you want to set it to be 0, right? So here, quick run, temperature set to 0. Again, this is the color of Llama. I was like, what are we prompting? So it comes back to say, hey, Llama is white, right? And you run it with Llama 3 8B, it is pretty consistent. Here you can see that it is the same response that you're getting back from the model. Now, let's increase, like if you increase the temperature to like 1.0, right? So here you can see the response has changed. The typical color of Llama is white. And so as you keep on trying it, you get different kinds of responses, right? So with the temperature 0, you get the exact same results, but as soon as you set it to 1.0, you start getting different answers. Next, over here, like LLMs are stateless in nature. So what that means is when you ask a question, it responds and it forgets what you asked, right? It is your responsibility. It is just like your REST APIs for the most part. You make a request, it remains. So if you want your models to be, for your LLM to remember what you had previously asked, it is your responsibility to include that as a part of the context. So I'm going to be talking about how we are going to do that. So here, there's a prompt here which is like, hey, what is the average lifespan of Llama? And answer it in few words. It says around 15 to 20 years. So this is what Llama 2 says. Now, when you run the same thing with like Llama 3, it comes back and says 15 to 20 years. Now, let's say we change this prompt, right? And now we say like, what animal family are they, right? Answer the question in few words. Now, when you run this against like Llama 2, sure, it responds, and it starts blabbering here. It really does not know what it is talking about, right? Now, let's try it with Llama 3 8B. Now, when you run this, it comes back and says mammal. So it is respecting answer in few words, like Llama 3 is doing better. But at the same time, it is still hallucinating, right? Now let's try it with Llama 370B here. And now this gets smarter. This is what I was saying. It's like better with reasoning, etc. So please provide the animal's name, and I'll respond to you with the family in few words. So as the models get bigger and better, they get really good with having a proper conversation with humans, right? Now, I promised you like we're going to talk about like how do you provide this context. So this is what we call as like multi-turn chat, right? So here we will continue to have like a history of the conversation of what was happening. Now here you see that as a part of my prompt, I will say, what is the average lifespan of Llama? And my agent got back to say that it is 15 to 20 years. And now I ask the question to say, what animal family are they? So I'm passing this entire thing, and now let's see what Llama 2 does. So now it comes back and says that, hey, it is part of the Camelidae family, which is the right response. Now, if you do the same thing with Llama 3 8B, now Llama 3 8B is also getting better. Now it has enough context in the prompt. Now it is able to come back with proper response to say, hey, it is part of camels, alpacas, and guanacos. Now, as the reason why I'm talking a little bit more about here, it is also to remember that like your prompt makes a lot of difference. So that's the key thing, right? So here, now let's get a little bit more specific. And now I'm going to be saying, hey, this is the context, but I want you to answer in one word. I don't want you to be too chatty, right? And when I ask Llama 2, it still says, hey, llamas are part of Camelidae family. Great. Now the same thing with Llama 3 8B. Now it is no longer having like longer sentences, but it is sticking to the point and saying it is camelid, right? So Llama 3, the takeaway here is it follows your instructions much better than Llama 2. And it all depends upon how you are prompting these models. Now, the next section here, we're going to be talking about prompt engineering. I don't know, like if everyone follows your Elon Musk. He recently posted, I think like 2-3 days ago, where he said, parenting is like prompt engineering for 18 years. So that's how, and that's what it takes, giving instructions so that people follow, right? So prompt engineering is essentially that. It is a science of giving effective prompts so that you get the desired responses. And this will help reduce the hallucinations with the models. So that's why it is very important to think about how you prompt your models. So in this section, I'm going to be covering a couple of techniques. The first one is going to be in-context learning. In the in-context learning, there are like a couple of kinds, but here you are giving the task, specifying the task as a part of your prompt, and then you're asking the LLM to respond based on the given context, right? So with zero-shot learning, you are not providing any examples to the model. So based on its pre-trained data, it will understand and it will give you the response, right? But with few-shot learning, you prompt your LLMs with some examples and your expected responses. By that, your LLM learns what you're expecting and then tries to answer based on what you want. So that is few-shot or n-shot learning. So we'll look at like a couple of examples here, right? So this is like sentiment analysis. So I give a statement in here to say, hey, I saw gecko. Give one-word response. So when you ask Llama 2, it says, it's interesting. But I'm looking for more about, hey, tell me whether it is positive, negative, or neutral, right? That's the sentiment that I would like to understand. And when you ask Llama 3 the same thing, it says neutral. So Llama 3 is doing much better than Llama 2, even without any extra effort here, right? Now, to make Llama 2 do the same thing for me, I do it by giving like a few examples about what I am expecting. So over here, I say, hey, classify, I love llamas, and I think this is positive. I don't like snakes, now this is negative. I saw gecko, now you tell me what is this sentiment gonna be. Now when you ask Llama 2, now it comes back and says, hey, this is neutral, which is what we were trying to look for, right? And now when you ask the same thing with the same prompt with Llama 3 8B, you get it back as neutral. Now, Vicuna, this is like also one of the Llama family. Now, when you ask what's Vicuna, like it does not have any other context, right? So when you ask Llama 3 8B, it says, hey, this is like fiber. When you ask Llama 70B, it does even better. It says, hey, this is the llama. This is like some of the examples. Like I still have like a couple of other things that I want to cover here, so I'm going to quickly skip over this section. At the end of the day, what biggest takeaway from this part is like the Llama 70B tries to explain the answers better because these are also like bigger models. Okay, so chain of thought. We heard this question coming up, right? This is like a very important technique within prompt engineering. It is just like us trying to solve a word problem, right? When you're given a problem, you try to break it down into different steps. That's the same thing that's also happening with the LLMs. Now, I give it a problem here to say, hey, you started with 5 tennis balls, and then it buys 2 more cans, with each can having 3 tennis balls. So how many tennis balls does the llama have? And here we are forcing the llama model to say, you answer to me in 1 word. You don't have to do the math. The answer is 11. But over here, Llama 8B says that it is 17, right? So it tried to do something and came back and said it is 17. But when you ask the same prompt with 70B model, you will get back the right answer. So this is what I said, better with reasoning, better with instruction, and processes your prompts better, right? Now, Llama 3 models applies chain of thought automatically behind the scenes. Like, that's the key thing, right? So it does better compared to like Llama 2. Now, when you prompt here the chain of thought, like how many tennis balls does Llama have, and you ask Llama 3 8B, which previously gave you back, remember, it gave back as 17. Now here, when it's like breaking down, you're not asking the Llama to answer in one word. Remember, the previous prompt said one word. Now we are not saying one word. It's like, do your work, whatever you're supposed to be doing. Now it breaks down the problem here in a lot more understandable way for the model and comes back with the right response of 11. Any questions on chain of thought before I move on? Okay, all right. So we still have 10 minutes? Okay. 8 minutes, all right. The next example is like knowledge prompting. This is what I want to talk about. So within like knowledge prompting, right, the way it works is you provide the context, you define the task, and you specify the desired output within your prompts. So when you do this, then your LLMs performs better. Now, let's take like a couple of examples here. Over here, we are talking about golf. And here I'm saying like, hey, the part of golf is trying to get a higher point total than others. Is this right or is this wrong? And Llama 3 8B comes back and says, yes, it is right, but actually the answer is wrong, right? So you want to be completing your rounds with as many lesser compared to the other players. So then I define the objective within my prompt to say that, hey, the objective of the golf is to play a set of holes in the least number of strokes. So now the model has this additional context and additional objective, and now we are asking the model to explain its answer. Now the 8B model comes back and says that, hey, the answer is no, which is the expected answer, right? And now the same thing when you try to do it like Llama 70B model, it is very similar. It comes back as no. It does not need the broader objective or the task. Again, bigger model, better reasoning. The next one is like, we speak about like RAG. I think Davit spoke a lot more about RAG than what I can cover in the amount of time that we have. But he did speak about like one topic, which is like relevant that I want to like demonstrate as to how to do what he was talking about, as well as one of the techniques. So this is like decomposition question. Like how do you break down a complex problem that you're trying to solve, like using RAG and Llama 3, right? So here, I'm going to be giving like a simple instruction to the model to say that, hey, you're a domain expert. You can break it down into complex. You can break down the complex questions into simpler subparts, right? So, and then try to find the answers within the document that was given as a part of the RAG implementation. So the question here is like, what's the revenue difference between Q1 of 2022 and Q2 of 2022? This is all I'm asking, but then I'm expecting my model to break down into smaller sub-questions. So when you ask Llama 2, it comes back and says like, hey, help me answer these questions, which is like, what is the time period being compared? What is the revenue data source? How is the revenue data collected? But I have already given all that information as a part of my prompt, right? So Llama 2 is not able to do that great job when it comes to this. But when the same thing, you prompt Llama 3 8B, it comes back with the right set of questions we should be looking for an answer for within the document that you have given the LLM. Here it says, hey, what is the revenue for Q1 2022? What is the revenue for Q2? Now, once I get these answers, then I will be able to answer the question that you're asking for. So takeaway, Llama 3 breaks down the problems and breaks down complex, sorry. This is my alarm that I forgot to turn it off to give medicines for my dog. Sorry about that. So that's how it kind of like breaks down the complex questions into smaller subparts. And with that, I will stop my talk here and open it up. Oh, one part that I do want to cover, I'm sorry. I have linked there are some of great resources that's available that is built and maintained by Meta employees. So this is the Llama Getting Started Guide. It has a lot of working examples about implementing various APIs and all of that. This is Llama Recipes. This is essentially cookbooks and examples of how to do certain real-world applications, right? So if you go in here, it has libraries that will help you with fine-tuning, quantization, how to integrate with other API service providers, how to build chatbots. It has working examples and notebooks which you can just take it and be able to execute and run with it. So you don't have to spend too much cycles trying to build proof of concepts. How to use Llama, that's the thing. We try to make it as easy as possible for everyone. There's also a deeplearning.ai course specifically on prompt engineering that is run by Amit Sangani, who is also my manager, where you can go a lot more deeper into prompt engineering. With that, thank you.
Thank you so much, Varun. Let's open this up for Q&A. And if you guys can just do me a favor and please stand when you ask your question. And when you're done, if you can just pass the mic to the next person or back to me, but even better, next person.
Sounds good. Hi, thank you for the presentation. Could you talk more about chain of thought, and how that correlates to tokens? So I noticed that, you mentioned that that the models sort of do chain of thought automatically, right? Or at least Llama 3. And I noticed that some of your prompts, it still responded with one word. And so I guess what I've seen from chain of thought is it gives you the whole output, right? So how does that correspond to tokens? Is it, I don't know, does it take less tokens if it's automated?
So in terms of so let me understand this question here properly. So your question is, if the model you're prompting here to say that use only one word to respond, does it take far lesser tokens compared to doing a chain of thought where it generates more tokens and indirectly impacts your throughput and number of tokens generated? Essentially, yes. Yeah. So, the way I would say here is the way wherever you're hosting your models or wherever you're using this API, you're typically billed against the number of tokens your LLM is generating, right? So if there are, with Llama 2, you had to do the chain of thought to kind of solve complex problems. But with Llama 3, you don't have to do that. As long as it is giving you accurate answers as what you are expecting, then I would say that the number of tokens used is far lesser compared to Llama 2. But if it is not serving the purpose, but it is responding in one way, but it's not answering, then it does not serve the purpose that you're trying to do. So it does reduce as long as it is solving your problem. That's the way I would put it.
Thank you for your presentation. I have two questions. One is for Llama 3 models. How long typically it takes to train the models, and what platforms do you use for training? And then second question is the number of words as input. Has it been increased compared to the previous model? And Are you looking to increasing them? Is it possible to copy paste, 100 pages of, book and ask for a summary of that or not?
So your first question was around how
long it takes to train the model.
Yeah, I mean, that's a hard question that is a function of multiple variables because it depends upon your data set, it depends upon what you're benchmarking against. It also depends upon how you are evaluating the models. So it's a hard one. I don't think there is a definitive answer that I can give for that one, unfortunately. In terms of did we increase the vocabulary size? Yes, we did. What that means is the number of tokens, the optimization here, to speak for numbers specifically, the new tokenizer is 15% more efficient than Llama 2. So what that means is it uses far lesser tokens to do the same job compared to Llama 2, which would essentially help improve the overall efficiency of your model.
Thank you for that insightful presentation. My question's on the lines of context. Talking about while passing, while doing the prompt engineering, we are trying to pass the entire. So it was about context when we were doing prompt engineering, and what I could see was, let's say I'm having a full end-to-end conversation with an LLM, for example, and in that conversation, it's a sequence of questions and answers.
Yeah.
So let's say I am on that nth question right now, wherein I'm asking the nth question, and what we saw is the model essentially needs to we need to essentially feed all the context that we previously spoke to the model about till n-1 is what I'm assuming. Now, I obviously with the newer iterations of Llama and every other LLM that is coming out, the token size is essentially growing, and I think with Llama it's 128K now. But my question is, will it not become exhaustive after a point to feed that big of a context? To give a more concrete example, let's say we were before this discussing the law use case, and in the law use case, let's say there is a rigorous question answering that could go on between a user and a chat bot. So in that rigorous question answering, there'll be a lot of context that will flow into the model. And after a point, you will be forced to perform chunking of your input because the model will not be able to take in those many number of tokens. So in that scenario, how are models like Llama 3 ensuring that they are able to preserve the maximum context as possible?
Yeah, so I think this problem is going to persist regardless of what model you end up using as soon as you start maxing out the context window. So it is not specific to Llama, I would say. It is like a generic application. How you build your application is. So there are various techniques to answer to your question. One, as you go through your chat history, some of them can become repetitive or is no longer relevant. So what are the techniques that you kind of apply that would allow you to summarize the previous set of conversations that should be sufficient enough for your chatbot to respond effectively to the next set of questions coming in. So there will be a constant pipeline of how you're cleaning up your previous prompts and summarizing it so that your model can effectively respond to the new questions that is coming up in the pipeline. And just a small correction, which is the context window for the Llama 3 is 8K. It is not 128K. The tokenizer length is 128K, which is how efficiently the models can compress the data. So that's the tokenizer. But the window size of Llama 3 is 8K, and this is something that we are looking to make it bigger and better as we release the future versions of Llama.
Okay. Okay, thank you so much, Varun. Let's give Varun a round of applause.
Thank you.
Thanks so much for being here, everyone. If you'd like to show support, please follow us on LinkedIn or Twitter and say you were here. We'd appreciate it. And what else? We also post content there, so check it out. What else? Meetup.com, that's where you can find future events, such as our future events. AI for developers. Ooh, that date's wrong. Should be May 29th. So we'll do that again on May 29th. So in 4 weeks from now, we'll have AI for developers. AI for marketers is May 15th. And AI for designers is May 22nd. So see you then. They're all on the meetup page. This is a test. What else? Let's do open mic. We have a few minutes. If anyone wants to make an announcement, you can stand exactly where I'm standing right now. And the LinkedIn live stream will see you as well. This is a way to introduce yourself before we kick off networking. You have the stage and the mic. Some topics could be job openings, offering jobs, looking for jobs, product announcements, startup ideas, consulting opportunities. This is by request. So if you want to just come on up, we have a couple minutes. All right, come on down.
How you doing? That was a great presentation. Thank you, guys. My name is Kevin Epps, and just recently I started this new position as Executive Editor-in-Chief of the San Francisco Bayview National Black Newspaper, which is a historical publication. And so as I take the helm of this organization with the wealth of data and content it's been around 48 years, so there's a wealth of content and publishing and things like that. So I'm in the process of aggregating and integrating AI, because that's what the conversation about, is like learning how to integrate that into this system and this wealth of information and you know, aggregate it in a way where it could be effective and be relevant, and the company can kind of be on the, you know, use AI to sort of implement some of the strategies and some of the action activities that's going on. So that's what I'm here. I'm looking for a consultant. So anybody who knows consulting around anything with that, I'd love to have a conversation. Company's been around, you know, it's almost a 7-figure organization. It's not mine. I didn't start it. I inherited it from my family, and I'm just trying to continue to push it forward and make it relevant. So we'll leave it at that. Thank you.
You got it. Thanks, Kevin. All right, perfect example of an announcement. Appreciate it, Kevin. Next, we have time for probably one more announcement. Let's do it.
Hi, my name is Bill Raymond. I am the host of the Agile in Action podcast. I don't know if anyone's heard of that before. I have about 22,000 listeners, and it's been a fun ride for a few years now. And of course, everyone's talking about AI, and everyone keeps asking me about AI. So I've expanded the Agile in Action podcast to support AI, and I'm also launching a new podcast. I'm looking for people that can help business leaders understand AI and how it can effectively help their business. And if anyone wants to talk to me, I'm here and I'm happy to talk to you.
Thanks very much. Time for one last fast announcement, like the fastest announcement anyone's ever made. Anyone else? Okay. Well, we do this every single time. Oh, come on. You got to just, don't be shy. Just charge it. Let's go.
Yeah, thank you so much. So my name is Ahmed. It's my first time in San Francisco. I'm based out of Saudi Arabia, and I believe I'm pretty active there. So it's an open invitation if you want to explore more, want to learn more about the Middle Eastern market in terms of tech and AI, feel free to reach out. Thank you so much.
Thanks, Ahmed. Really appreciate it. So let's do some networking. This is my email address if you want to reach me. And let's enjoy some pizza, some drinks, and get to know each other some more. Thanks very much, guys.